Hey everybody, it's Mega Mondays. How is everyone doing? We're going to start with some 201 today. So let me get that loaded up here in the background. Is everyone having a good day? It is Monday. Stats 1 has an exam. Through 2474 have some assignments due. So much work, so much statistics. I'm loading up the questions. Quiz 8 has been a big question. A lot of students have been emailing me. So I'm gonna start with some quiz 8 questions. Then I saw some 320 questions in the chat. There was a little 474 talk also. So I'm getting this loaded up. Mubot is here. Everyone say hey to Mubot. Feel free to check your points. Oh, Nicholas has already checked his point. Nicholas, an extra 100 points. Mubot, tell us a quote. How are you doing, Mubot? Good to see you here, Nicholas, Chloe, 8. Mubot, calm down, Mubot. Mubot's. You can just read what Mubot's saying in the chat. So let's see right here. Let's go to the next one. Let's go to the questions right here. I'm going to pull these up on the main screen. Awesome. Let's go ahead and take a look at these questions. I think I got everything good to go. Great points there. Good to see you here, Wilson. Feel free to ask some questions. We're starting off with a little 201, but feel free to put your 320, 474 questions in here. Hey, good to see you, Harina. Good to see you here. Let's take a look at this on the main screen over here. Let's do it on these Mega Mondays. Okay, so with this first question, we're doing regression wisdom, which is chapter 8. And the big thing about chapter 8 is it's basically chapter 7. So I kind of teach chapter 8 in chapter 7. So a lot of people were wondering, wait, when are we doing chapter 8? And we did for like the last 40 minutes of class because there's not that many topics. If you look at the review sheet for it, it's got extrapolation, lurking variables, correlations not causation, residual plots. And we're doing a lot of review of chapter 7 right here. We're to ask something like, what is the correlation? So correlation is R. We should instantaneously, let's put some notes right here. We got new pens today because the pens are acting all crazy. So R is correlation. Oh, it's doing that thing again. R is, oh, there's what's going on with the black pens right there. Really? I don't know. I got to look into why it's doing that. The Nito pens don't do this though. R is equal to correlation. It started doing that just randomly on Friday. And then R squared is the percent of variation. This is a tip for 320. It's blank percent of the variation in Y is explained by the variation in X. I'll have to zoom out right here. You know what? I think it'd be easier if I just wrote it. If we write blank percent of the variation in Y is explained by the variation in X. And that should help out 474 also, but all this is R squared. So make sure to do your context. That's why I always, oh, that pen's always doing that. I have no idea what happened on Friday. Randomly recording videos and stuff, and then all of a sudden it does that. So weird. Computer's haunted. So blank percent of the variation in Y is explained by the variation in X. So what is R squared? It's just R squared. It's correlation squared. R ranges from values. R is contained within -1 to 1. And then R squared is contained within the values of 0 to 1. Reason being is it's a percent of variation explained, and R tells us the direction of the correlation. Make sure we don't have sounds playing in the background here. Routing, we're good. Okay. So we understand the difference between R and R squared. All this excellent stuff to get back to the question right here. What is the correlation? So we're just going to take R squared and square root it. Now, anytime you square root R squared, 201, 100-point question. If I square root this, what must I do going from R squared to R? So I just took my R squared and I went to R. What do I need to do every time I square root this? Every time I square root this, I need to look at something and see something. I need to look over here and be like, okay, that tells me something. Because I've had a lot of people say, well, how would you know? When you square root it, how would you know? And there's a good way to know with this. How would we know if it's positive or negative? And I know it's positive because I'm going to look at the slope. Exactly, to see if it's negative or not negative. Exactly, Wilson. Great job right there. We want to see it's positive because the slope of the line. You can also see the coefficient of the y variable right here. Slope is positive. Exactly. So it says round to 2 decimal places. What is the correlation? Oh, that's a really strong round on this. It's really want to round it that much. The intercept, on average, interest rates during this period increased because we have a positive intercept right here. Now, a few people emailed about this. This right here wants to 2 decimals, and that's going to round up. But this is, if you notice the scale here, it's not 26%. That 0.26 is not 26%. It's 0.26. Each year since 1950, we would expect the increase in rate of these bonds, I think they are, to increase by 0.26%. If it was 26%, it would go off the scale very quickly. It is a decimal of a percent. And they started, or we would expect in 1950 for this to be the starting interest rate. And 2 decimal places, hopefully, someone tell me if I make a mistake on my rounding. What does it predict for 2010? Well, that's going to be an extrapolation of the model, a word we should know. Extrapolation is when we predict outside the bounds of the x's of the model, and it only goes up to 1980. How do I know it only goes to 1980? Because the graphic right here is going 30 years into the future. So I'm going to bring this over to the Word document and make sure we know how to write the regression equation. The regression equation is going to be y hat equals b0 plus b1x. Now we need to plug in here that we are predicting the rate. So it's the predicted rate is equal to the intercept of 0.17. I'm just going to round, or 8 round up, plus, and then 0.27, and then years since 1950. So we'll put years since 50. There we go. So that's the equation right there. But when we solve it, please make sure to carry all decimals. You're going to see as I plug in the value right here, it asks the year 2010, which is the distant past now. So this is predicting for 2010, so you wouldn't plug in 2010, you'd plug in 60 right here, because it's years since 1950. So we're going to plug in 60. We're going to carry all the decimals up top. I'm using the number up there. And there's the what I'm going to add to the intercept. Carry all the decimals. And there's the answer, 16.1 or so. Let's see how it wants it rounded. And round to the nearest integer as needed, so we should be good right there. Why do you expect this to not be accurate or accurate? It's going to be an extrapolation of the model, so the only one I see with extrapolation is this. It's 30 years beyond the scope of the x's in the model. Extrapolation is when you go outside the x bounds. We can't really negatively extrapolate here, but we can extrapolate into the future. And we do see that the model's getting really bad near the end, so it makes me really worried. No! What did we do? It had to have been a rounding. Extrapolation, we're right on. Who sees it? Who sees it? It's because when I know what I did. I didn't delete the number when I replaced it. Man, please tell me if you make an error like this. That's so ridiculous. No! It was just I typed in the 7 because we had to round up, and I didn't delete the 6. Yeah, and it was because I was changing it the 6 to a 7, and then I didn't delete it. That's how it goes. Please tell me if you make an error like that. I will correct it. We didn't get anything wrong. My Pearson just cheated. We say, not today, my Pearson. Not today. On this next question, we're going to get 100. Boom, we got this. You look at this graphic right away, and what do you say? QQ straight enough. No outliers. Plot doesn't thicken. What looks to be the biggest problem with this graphic right here with QQ straight enough, no outliers, plot doesn't thicken? Is it quantitative? Well, it has to be a scatter plot. All scatter plots are going to be bivariate quantitative relationships. So the first condition right here, which is bivariate quantitative, these have to be bivariate quantitative. It's a scatter plot, so it has to be. Is it straight enough? That's kind of an issue, except for something over here. I mean, because with that thing, it might kind of bend this way. But the straight enough's really coming from an outlier, and I don't see issues with the plot thickening. It looks to be about the same. If we were to remove that outlier, I'd say we generally have a good regression right here, and that I believe is humans. These are gestation periods, and that's the gestation period for a human, and the life expectancy of a human, 80 years, not so bad. Hopefully we all get 80 years. And so right here, for this data, the correlation is 0.539. This is not a very strong relationship. It's moderate. Do you think the association would be stronger if humans were removed? So let's go ahead and see what happens if we remove humans from this. If we have a plot without humans, we'd have this. And with humans, we'd have this right here. So if you notice, the more it looks like a 1, the stronger it is. So this blue graphic I have right here is stronger. So the correlation would go up. Stronger, both the slope and the correlation would increase. Yep. Is there a reasonable justification for you moving humans? Sure, just say it's for non-humans. I mean, as long as you're saying your study, we studied non-humans, cool. Here's the scatter plot. The association is, and remember before it said not too strong, so I don't think we're going to go weak now. And perfect, what is perfect? Perfect means that every point is directly on the line. To have a perfect, not tricking me, I know it doesn't work. For it to be perfect, it has to look like this. This is perfect right here. Perfect means every point is directly on that line. So it's not perfect at all. We know it's not perfect, so moderately strong sounds good. Interpret the slope. On average, for each year increase, for each additional year, we would expect that the gestation period increases by about. Now we look here at the coefficients. Now what's very important is you always need to remember to identify what your coefficients are. So when I get this output right here, I'm going to bring it right into Word, and I want to make sure I take notes that the constant, that's what they're calling it in this output, we don't usually call it the constant, is b0, and the slope is b1, and this is the name of the x variable. So this is just the intercept right here. Just using a little bit of different terminology to see if someone were to use different terminology, if you would get it. So we can write our regression equation right here. I'm going to write it rounded. That we would have here, we're predicting the gestation period. So I'm going to write gest predicted equals to 90.41 plus, because that's a positive coefficient, 13.1 life x. So this right here is the equation. We'll put this in parentheses right here so it's a little more clear. But we can write the equation with y hat equals b0 plus b1x. And we're just using the equation. Could you explain the difference between p-values and r values? Yeah, of course, Eric, anytime. So r values represent correlation. So when we look at a correlation value, correlation can range. So all correlations, all possible correlations, not the code, all correlations will have values that range, are contained in the -1 to 1. All p-values are contained within 0 to 1. P-values are probabilities. Correlations measure strength, direction, and form, and kind of are impacted by unusual features. So if you look at a plot up here, you might have a correlation right here that would look like this. Now, can you take a guess at this correlation right here? Can you take a guess at this correlation? Can you take a guess at this correlation right here? What would be the correlation of this plot right here? Any guess of what this correlation is equal to? And then we could also talk about what the r squared is for this. It's going to be equal to 0. Nice job, Eric. 100 points. Great work. R is going to be equal to 0 because there's no linear correlation between this. Now, r squared is equal to what? R squared is equal to 0 because it tells us that the line explains 0% of the variation in y. Like the relationship between x and y, x or 0% of the variation in y is explained by the variation in x. X doesn't tell you anything about y. Because think about this. If you were to predict here with x, you'd predict this value. If you were to predict here with x, you'd predict this value. Do you see how if you use x to predict y, you never change what you're predicting? So x is not really explaining y. If you use x, the equation of the line is just constant, and so x does not actually explain y at all. So 0% of the variation in y is explained by the variation in x. And it means as we travel along x, like as we do different x values, it doesn't explain any of the variation in y. What do we mean by the variation in y? These points have variation in them, and we want, when we go to different values of x, the variation in x to explain the variation in y. So what is a p-value? This is the complex topic right here. A p-value is going to be the probability of our results or results more extreme occurring by random chance variation given that the null is true. Now the null for this is going to be no correlation. Each null is different for each test. Be very careful, there's not a consistent null. Do not memorize that when a p-value is low, it means there's no correlation. Do not memorize that when a p-value is low, it means there's no correlation. So what do you think the p-value is right here? Do you think what we saw right here was very likely given there's no correlation? Was what we saw here very likely given there's no correlation? This graphic that I've drawn, is that a very likely graphic given there's no correlation? If no correlation is the truth, is that something likely to see over there? If there really is no correlation, is that a very likely thing to see? And then think about what likely means. Would that graphic on the far left be something likely to see? Hey, Maria, good to see you here. Would that be very likely or unlikely to see if there's no correlation? Remember, we have the Kahoot tonight, big Kahoot. Might do a bigger prize than $20. If we have like 200 people playing, I'll be like, heck, let's do first, second, third place prizes. Let's see if we can get 200 people playing. It's very likely, exactly. So what does that mean the p-value is going to be? If this is a very likely thing to see, the p-value is going to be very, very high. So the p-value here tells us that what we saw was very likely given the null is true. And so we would say that what we observed here is likely given there's no correlation. So the p-value it's related to strength in some ways, like stronger correlations are less likely by random chance. But I'm going to put a video in the chat right here from the playlist. I've made some new playlists, or I made a big mega playlist review for the test. And I think, Eric, you might have watched one because I think I saw a comment. Thank you for the comments. Always love the comments. So let me go grab this video right here because I do have a video talking about all 3 times we use p-values for the test. So if you see this in the chat right here, it's no, not that playlist. Watching my own videos while streaming. And where is the statistical tests and p-values? Okay. Okay, so this should be all 3 times we use p-values on this test to differentiate between all 3. So there's a link in the chat right now to all 3 times we use p-values on this test to differentiate between testing for normality, looking at the correlation, and looking at the slope of a line. So does that make sense right there, Eric? There's 3 times we use it on this test. We talk about p-values, and this is one of the 3 when we look at correlation. So hopefully that helps out. Yay, good. That's awesome. No, and just keep asking questions. Like we're doing this question right here, but no, feel free to ask because by about blank days, that's the slope of the line. Oh no, I don't know how to type the slope. 2 decimals. A certain mammal has a life expectancy of 15 years. Figure out the gestation period. So we needed to write the equation of the line. We wrote it right here. So we're just going back to where we wrote the equation. Remember, we identified what the variables are. And so it says 15 years. So we plug 15 in right here. And then we're going to use all the decimals. We just have it written out a little shorthand right here. So I'm going to type 15 times it by 13.1119. And then I'm going to add to it 90.4116. And there it is. That is the gestation period. Really long, just humans have longer, I guess. And how many decimals? Do not round, then round to 1 decimal place as needed. Okay, hopefully we did all the rounding correct. Is that all the answers? I'm so scared. We got the first one wrong. Do it. Yeah, we got it. We got it. Don't be scared. Don't do that. We got this. It's so easy to misclick something. This one tricks a lot of people right here. This is, I believe, is it the Kentucky Derby times? It's the cyclist times. It's the Tour de France? Some sort of race. And so what we're looking at right here is different races, and it's a time plot, actually. A time plot is a special case scatter plot. You might want to remember that if you're watching the Kahoot tonight. A time plot is a special case scatter plot where time is on the x-axis. If you look at the data right here, you'll notice something. There are no races in the 1915s to 1918s. And then there's no races. There's another period of no races. I know there is. There we go, in the 40s. So we got a period in the early 40s of no races, and we have a period in the teens. Okay, let's take a look. So remember, there should be gaps. This one doesn't have gaps here in the teens. That one is wrong. This one doesn't have gaps. That one's wrong. This one has a gap in the teens and has a gap in the 40s. That could be right. This one does not have a gap in the teens. Just by using the gaps right here, we can get it. And just, if you saw what I'm looking for this period of no data right here when World War I was happening and no data right here when World War II was happening. So these are missing data points. And once again, you can observe this by looking here and to see there's no data for 1913 to 1918. You can observe this also by going here and seeing there's no data for 1940 to 1946. And then when you look at the graphic, you should see those periods of no data for both here and here. So now we've identified the right graphic. Describe the relationship of average speed by year. Be careful to point out any unusual features. There is some nonlinearity to this. If you notice, it kind of weaves in and out. So I want to see if anything mentions the nonlinearity. Okay, the relationship is positive. They're all positive. With a moderate amount of scatter, they're all those. There's a general linear trend with no races from the blah, blah, blah. So it's either right now A or C. Okay. There's a oh man, tricky stuff. I'm going to say general linear. There's a general linear trend. There's some nonlinearity right in here. It's linear. Charlie, you're awesome. Confirming that we got the right answer. There's only a little, since it says general linear, it doesn't say there's a strong or perfect linear trend. It says it's generally linear. So I agree. It's generally linear. I just hate those ambiguous questions where they're like, is it generally not linear? It should just say not linear trend, because then I'd be like, no, it's mostly linear. It's just got this little issue right here where we see this dip in times. So generally linear. Charlie, 100 points, making sure we get the right answers right here. Find the regression equation. So to find the regression equation, I think the easiest way to do it is with jump. We're going to copy these numbers right here. We're going to hop into jump. Class is not over. Just loading up jump. Don't leave yet. So here's the biggest thing. When you load this data into jump right here, when you load this data into jump, you need to do edit, paste with column names. If you make a mistake here, go to File, New, Data Table, and start over. Do not try to fix it. I'll show you. If you do this, it changes what the columns are, and it's more work to fix it than it's worth. Go to, so don't do that. This is the error. This is the bad one. This is the bad thing to do. You want to go to New Data Table. We have a new data table open, and you want to go to Edit, Paste with column names. You can see that both variables here. Yeah, and the Excel solver too works really well for this. Did it have enough rows to do it? Did I make sure it had enough rows? It worked, did it? I think when I first made it, it didn't have enough observations going down, but I think I changed it. Hopefully it worked. If you got the right answer, it worked. So, because I sent out. Okay, good. Yeah, I made that solver, or Tiny Brian made it. So, yeah, and we're doing regression. Right? We're predicting average speed by year. And there we go. You can see the plot right here. So you also get a visualization of the plot right here. You can see the gaps. We can fit the line of best fit. And we get the variables here. And slow down the video. Make sure to pause if you're trying to see where I clicked to do those things. And now we just get the answers. Let's do it. So we're looking right here at the intercept. The intercept was, where's the intercept go? The intercept is this. Well, let's just copy them both. Can we copy them both? It's negative intercept. Watch out, negative intercept. There we go. Look at that. We'll just copy the whole thing. Negative, round to 2 decimal places. Okay. And then let's grab this one. And round the year to 3 decimal places. Really? Really, Mike Pearson? Really? Okay, I think that's got it. I better like these answers. I think we rounded them all correctly. Rounding's the hardest part of these tests. Are the conditions for regression met? So I'm going to go with yes, because it called it mostly linear. It's saying yes, the relationship is not straight enough. That'd be no. Yes, the variables are quantitative. The plot seems straight enough to know there are no real outliers. It's no, is it? Yeah, so be careful. I'm glad we're doing this one right here because this one's tricky. No, the relationship is not straight enough in the early part of the 20th centuries. So they're talking about this issue right here. These things are, you're pretty sure? See, that's what they're trying to point to. It's like one of the points of this question. If you look, they're purposely showing you this right here and you're meant to notice it, that there's an issue. Yeah, that's a lot of points that are going to go below the regression line. If you look at the regression line, that's kind of an issue. Yeah, that's a pretty big issue. You know what? Here's the way to really check. Wait, do we not have a lack of fit test? Did they take that away? Where's the lack of fit test? When did Jump take away the lack of fit test? What? Am I going mad? Was there never a lack of fit test on here? I think they took away the lack of fit test. Well, I'll be. My Pearson is so tricky. And Jump took away its lack of fit test. I have no idea why. I need to load Jump 14. Am I in Jump 14 or 15 right now? We should have a lack of fit test right here, which would tell us if there's an issue. And there's a lot of ways to look at it to see if the fit has a problem. There's a statistical test, and it's more work to do than it's worth it to actually do it. Let's find out here. So you're saying no, the relationship is not straight enough. Yeah, we got it. Nice job there. Nice job, Charlie. There's a statistical test we can do, and I don't know where Jump's hidden it now. Maybe just not enough people were doing it. Are you taking questions? Yeah, I think a lot of people want that one. We'll do one more 201, then we'll hop to 320 here. Let's do one more 201 question. Oh, this is too easy. We got this one. We'll do that one next year, Andrew. We'll do the 325C. So when you look at this right here, the best way to understand this is to think about what would happen. So if you look at this plot, you've got right here a box. The blue dots are going to make a what correlation? The blue dots are going to make a what correlation right here? The blue dots, as I keep making this object right here, the blue dots would make a what correlation? Question 2, you bet. We'll do 320 right after this question. You got it. We got question 5C and question 2, exercise 6. You got it. Right here, this box would make a what type of correlation? The box right here would be a correlation of what? The blue box would be... So remember, it's a box. It's like this. It's like that. The blue box would make a correlation of 0. And we can confirm this. 2 seconds. I'll pull up R right here real quick. We can confirm this. Just got to close down everything. Don't save. Clear out this. Clear out that. Okay, there we go. Ready to go. Let me run the core demo. Don't have core demo. 2 seconds. Library, write class, and now we're going to run core demo because we're kind of going into the next topic stuff. So this is a thing. Oh, sure, it's too large. And so this is a thing that lets you look at correlations right here, and we can make the box figure like this. And take a look. The correlation's very, very close to 0. Now, if I'd put a point way up here, what's it going to do? 14 on the practice test. Yeah, I think I might have time for that. And there's a video on that one too. There should be a video on that one, Eric, in the practice test questions. If I don't get to that today, since we got 30 more minutes or so, if I don't get to it, there is a video on it. I want to get to it, but if we don't, there is a video. If I put a point all the way up here, what would happen to the correlation? If I put a point all the way up there in the corner, as I just start to cough. If I put a point all the way up there in the corner, I'm trying to find you that video. Here we go. Here is the practice test playlist review. There's that. A point all the way up here in the corner would make the correlation very strong. Might need to get some water. So now the correlation is extremely strong, which means this point A would be the strong correlation, the strong positive. Yep, point A is all the way up here. Now point E, think about where point E is at. Point E is all the way down here. So this is going to make the correlation the most negative. So down here, the correlation would be the most negative, and so that's going to be our answer right here. So E is the one that is the most negative. So this is going to be point E, and now we have D, which is closer in. So D is going to be not as negative. Watch this. We go over here where D is at, and it's still negative, but not as negative. So D is going to be this one right here, which is our second most negative. And then the interesting thing is C and B. Those are the tricky ones where people usually get tricked. Now, C is directly below the middle of this plot, which will not change the correlation at all. Actually makes it even closer to 0 for our plot. So that is going to keep it still at 0 for C. So right here for C, and then B is going to make it slightly positive. We could go here and look at what happens when we add in B, and B is going to make it, we'll go right here where B's at, slightly positive. We're getting almost the exact same values they're getting, and we can kind of see what happens when we do this, and we check, and we got it right. A little tricky one right here, but it shows you that outliers can do what? What do we always say outliers can do as I get the next thing loaded up right here? Outliers can do what on these Mega Mondays? What can outliers do? What in the world can outliers do? Any ideas on what outliers can do? Anyone know what outliers can do? We're getting 320's assignment loaded up here as we speak. 320 assignments. And we have a review video for 201 for every chapter now. There's a review video for every single chapter. I did new reviews this semester, went through all the topics, new reviews for every single thing, made 9 videos this weekend. That was, I got halfway done and I was like, what did I do to myself? It's like, why did I? Oh, I need to change this. Okay, I got to change something real quick here. Homework 4, let me make sure. Or else the solutions will get released. So I'm fixing so the solutions don't get released while we're doing this. We don't want the solution. Oh, did someone already fix it for me? Nope, not fixed. Okay. Now the solutions will not be released while the homework is still out. That's great. Anything and everything, you're right. It really was the upload grind. It really was. I was like, I'm gonna get this done, and I had a few done really quickly. You can see the change in t-shirts if you watch the videos and you just go through and you're like, oh, Brian's wearing his Captain America shirt. Oh, Brian's wearing a blue shirt. You'd be like, oh, this took place over a longer period of time. Because each video I record like maybe, I don't know, depends. If it's a 20-minute, 15-minute video, I'm recording like an hour and a half of footage probably. I do multiple takes and everything. I want it to look pretty good. Yep. So let's get back into this right here. Let's talk about some 320. Heading over to the main screen. Let's do it on these Mega Mondays. Okay, we're back on the main screen right now. I'm going to clear this plot out of the way. And I think the first question for 320, let's go back to the beginning. Someone asked at the very start of this, questions 8 and 9. What are questions 8 and 9? Oh, he's at the very start. Questions 8 and 9, all the way here at the end. That's question 5. Wait, question 8 and 9. I think someone asked about 5A. Let me see here. If you're here for 320, let me know. I'm going to look for the questions at the work. Can you go over question 2? Exercise 6C. So we got to load up those two. Okay, question 2. Question 2 is right here. Okay, so this one right here, you're going to put in an ID number. I'll just replace mine right here with something like, there we go. That's my ID. Put in yours, but I'm just going to put that in. And we're going to run this right here, and we create our random data set. What strength is appropriate? And I think I remember which two we're analyzing. Are we analyzing... Well, I'll do something similar. So working a similar but maybe different question. Sorry, it was question 4 and 5, but actually I say, oh, sorry about that. Working on similar but different questions. Okay, so working on similar but different questions. Let's look at, can't remember which one. I think you're using tip in USD to predict bill in USD. Let's use someone's bill to predict. I'm too afraid that everyone's going to do a different thing. I'm just going to do the one that is. Okay, let's make sure we grab these properly. It's bill. I'm going to do a trick right here. Here's a trick. Attach. Yeah, it should do it. EX2 tips, and that should do it. Yeah, it should be safe. And now bill in USD tilde tip in USD. The reason this is auto-completing is because I used the attach. And actually, I do have it reversed because think about what the explanatory variable is. Does the bill explain people's tips? So it's important to think, what is your X and Y variables? So tool 1, if you're still here, we're talking about what variable do we use as our Y variable? What variable do we use as our X variable? We want to understand why people tip a certain amount. That's the Y variable. Like, why do people tip a certain amount? And the X variable is, well, maybe the bill they have on their restaurant bill explains it. So we need to do data equals and EX2 tips. And I think we're good. Plot too large. No, you got to go here. You got to go here. And then you got to look at it. Okay, so what do we have going on right here? Well, we got some issues. And I see some stuff. QQ straight enough. No outliers. Plot doesn't thicken. What are the issues? QQ straight enough. No outliers. Plot doesn't thicken. What are the issues we see right here with QQ straight enough? No outliers. Plot doesn't thicken. Do we have two quantitative variables? This goes back to 201. Two quantitative variables. Two quantitative variables. Do we have two quantitative variables? QQ, two quantitative variables. I see bill, 100 points first answer. I see tip. That means we have two quantitative variables. Straight enough. Is straight enough an issue right here? Is straight enough an issue right here? Is straight enough an issue right here? QQ, straight enough. Is straight enough an issue right here? Do you think straight enough's a problem? When I look at this and I think about a line going through it, here's how we look at straight enough. See if it really is a straight enough. I agree, straight enough's not an issue. Bingo, nice job there, 800 points, great work. So straight enough looks to be fine. Let's go over here and drop it into here. Let's go grab our pen. And straight enough does not look to be an issue because a straight line would go through it. I do see an outlier at least right there. You might say, well, that's not that big. We can forego that outlier. But then we get into plot doesn't thicken. And plot doesn't thicken is what we call heteroskedasticity. Oh, I'm trying to think. Someone told me that there's less points here at the end, and there are less points, but the scatter's also larger. So we'd expect less scatter with we'd expect less scatter with less points, more scatter with more points. So to me, this definitely looks heteroscedastic. So since it looks heteroscedastic, what seems to be the issue? Which are we going to use? And let's do a quick review. Because what we have normally is we have Pearson correlation. Pearson is for linear. Pearson is linear. We reviewed this last time, but it's good review. We need to know these things pretty quickly. Spearman is ranked-based correlation. And Spearman handles heteroscedastic. It also handles nonlinear. It handles outliers. And the graph must be monotonic. So what issues do we see right here? I see a heteroscedastic relationship that is, it handles nonlinear. It doesn't have to be nonlinear. It can handle nonlinear. It can handle something that if it had a plot that looked, I think that's not going to hit my head. If it had a plot that looked something like this right here, it could handle a nonlinear relationship. It could handle the nonlinear relationships, but they still have to be monotonic. They go in one direction. So what looks to be the proper thing here, Spearman or Pearson? What do you think we should be using, Spearman or Pearson? I'm basically doing the question right now because now we're wondering, does this mean? Yeah, I would agree. It's probably Spearman. Due to the outliers, due to the heteroscedastic nature of the relationship, it seems better to do ranked-based correlation on this, which is Spearman. So I'd probably go with Spearman. We've identified outliers. We've identified differences in strength. That doesn't really look to be an outlier. It looks to be a symptom of the heteroscedastic nature of the relationship. So going back to the other questions, wrong button. Where's our? So many little things. Going back here, there's that. Is the relationship statistically significant? Anytime you see statistically significant, you should automatically think this. If I hear statistically significant, I'm going to automatically look at this p-value. Boom. So I'm going to look at the p-value right here. Oh, Pearson's misspelled. Pearson. So when we think about is it statistically significant, we're just going to look at p-value. Only p-value. That's the only thing we look at. Boom. I'm going to let you decide if that's statistically significant. Because 8, should they know instantaneously when they see that if that's statistically significant? The rule is if the p-value is below 0.05, it's statistically significant, or below alpha, which is assumed to be 0.05. So if it's below 0.05, statistically significant, yeah, we should know instantaneously that's statistically significant. We just ask, is it below 0.05? Would our choice matter on the statistical significance? Nice job, 8, another 100 points. I'll let you decide if your choice would change. I think that's got it. And so you were wondering about 8. You're wondering about questions 4 and 5 in R, but exercise. Oh, 8 and 9 on the homework packet. Cool. Which part of 4 and 5? 4 is asking us. Okay. Visit the site right here and choose a correlation. I'll report the 2 variables. Just make sure it has. A lot of people make mistakes on this and they don't have 12 observations. So make sure you have at least 12 observations. That's kind of key where people usually make the errors. Screenshot's a word. And report the 2 variables you selected. Report the value of R, report the value of R squared, and interprets its value. Interpreting R squared is blank % of the variation in Y is explained by the variation in X. Very key right here, and we should know that we're going to put in the values for what go here. So blank % of the variation in Y is explained by the variation in X. Don't just write that. Make sure you have your values in there. The values you selected have a statistically significant correlation or association. They also have practical significance. That also has practical significance strong. Explain whether you think the association is cause and effect. And so we might think something is cause and effect. Like I think the reason people buy ice cream is because it's hot outside. I think heat causes people to buy ice cream. You think, oh, it's a hot day. Let's go get some ice cream at Marble Slab. That'd be so nice. But you can't you have to be careful when you think of cause and effect. On question number 5 on chapter 8 quiz, use a linear model to predict the value of y and x from far from the ones used to the model. It's called, is the right answer. Yep, Maria, you're right. Extrapolation. Hey, Colin, good to see you here. Happy Monday. Maria, 100 points. Great question asked. That's extrapolation because you're outside the x bounds of the model. Extrapolation is when you're doing predictions outside the x bounds. I'm going to draw what I drew last night. So last night when I was doing the drawings here, I draw the graphic here. You've got your x, and you can make predictions. This is your you can make predictions here, like if you have points that go up to here. So you can make predictions within this boundary, and then outside of here is where you're doing extrapolation. This is what I was drawing last night. So these are the extrapolation zones anytime you're outside the bounds of your x bounds of the model. So extrapolation is making predictions outside the x bounds. So these are extrapolations of the models. Extrapolations. There we go right there. Nice job. Good questions. Be working on them while you're here. Ask those questions in the chat. We can confirm or deny the answers, but those are extrapolations of the model when you predict outside the x bounds of the model. 8, was there a specific one you were wondering about for the, I'm trying to see which ones you want for 320, so I can talk more specifics or maybe kind of generalities. I like to do parts of the assignments and then have people think about other parts. The core demo right here, I don't know if it was one of these for the core demo. It says generate a scatter plot which has a correlation of negative 0.8 plus or minus 0.02. So within 0.8 by that much, negative 0.8. Have this correlation be displayed in the upper left. Once this has been done, click the export button. You can screenshot it. You can just screenshot it if you want. So for question 4, exercise 8, do we have to click the link? Yeah, you should go to the Tyler Vergen site. That's the guy's name. And then you should look for correlations between two things. This should work, right? It's not going there. Let me go to this link here. I'm going to go to on my other page. Let me go to it and we'll pull it up right here. There's that. So let's go ahead and take a look at that. Okay, should work, right? Cool, we're here. We're on his site. Let's bring it over here. Here we go. And so choose a variable to investigate. Let's look at so many miscellaneous variables. View variables. What variables do we have? That's fun. So many U.S. uranium exports. So let's go to U.S. uranium exports. And it's looking for correlations with U.S. uranium exports. So we've got here, these are obvious. This is a cause and effect right here. Total ABA lawyers nationally. So juvenile drug arrests, spending on science. That's, everyone does that one. Cost of red delicious apples. That's interesting. So here is the correlation between how much uranium we're exporting and the cost of red delicious apples. So you'll notice as the cost of red delicious apples go up, we do see an increase in the how much uranium we're exporting. So, you would think, is this cause and effect, or is this just by random chance? Or maybe both are, hopefully not everyone uses this. I know there's so many falling from ladders, dying, and all this stuff right here. Oh, Wilson, email me about that. We'll fix that, Wilson. We'll fix that. I don't ever pull up grades on here while I'm working online, so that way I don't have to worry about it. But send me a quick email on that. We'll fix it due to rounding. Totally, we got that fixed, Wilson. But this would not be cause and effect. This is, and then just screenshot this. Go to your screenshot button. You can drop this in your Word document afterwards. I would take this right here, and I'd screenshot it like this. Oh, we need the correlation, so we need that correlation. Let's go right here. There we go. So I'd screenshot this, and I'd just drop it right into my Word document. And yeah. Does this make sense what to do right here, 8? That we're going to go to this site, find a spurious correlation or one that might be real, and then we're just going to talk about it. And also what we should do is we should take this correlation down below, and I could say it is true for this graphic that because the correlation is 0.758, we're going to take 0.758376 and we're going to square it. And that 57.5% of the variation in the cost of red apples, red delicious apples, is explained by the variation in crude oil exports. 57.5% of the variation in the cost of red delicious apples is explained by the variation in U.S. uranium exports. So yeah, it's pretty insane. It explains a lot of the variation, but it's probably just spurious, meaning it's just one of those things that happens, or maybe it's connected to like an economy variable. Like as the economy grows, or as there's more people, we see that we export more items, and we make the cost of items go up. It's kind of like a time thing. They're both connected to time has increased our export, time has increased the cost of an item. So, because most things generally cost more over time, like you could correlate the cost of any two items and they'd probably have a decent correlation because time. So, awesome. Let's look right here. So, let's do a little more 201. I think we got time for a few more 201 questions here. This is the same one. No, that's not fair. That's going to be E. This is going to be, which one's going to be, that's the, wait, got to make sure to do it properly here. So that's the most positive. You're welcome, 8. You're welcome, A-time. So that's the most negative. A is the most positive. C is going to keep it at 0. And then B is slightly positive. And then E should be, 2 should be D. I hate the way they do the numberings on this. Did I do it? So scary to think you get one wrong. A variable, and we just need to make sure the assignment 4 is due on Wednesday. It's due on Wednesday now, right? I've changed it, correct? I think I moved it, unless I forgot to hit save. It should be showing up on Wednesday. On question 2, I keep getting errors saying eval parse text, bill in USD not found. You might need to include what I make sure to. I ran a little bit of secret code right here. Secret code. The secret code I ran was this. So after you run all your code up here, after you run all your code, oh, no worries. I'm just making sure to. Sometimes I forget to hit save on things. You have to run this code right here. You also need to make sure to have this bit of code. So I'll just drop this in the chat. Make sure you have y tilde x comma data equals. Good to see you here, Jacob. Y tilde x comma data equals. So it's y tilde x comma data equals and your data frame name. So, and if just make sure to run this code up above. Maybe that code wasn't ran, but that's the format right there. Y tilde x comma data equals. And we put in the y variable, tilde the x variable, comma, data equals, and the name of the data frame. Just make sure to run all this code up here above. And I did this to get the autocompletes on the names. If things are not auto-completing, like when you type ex2, it doesn't autocomplete, then there's no ex2 tips over here in the global environment. So also you can check your global environment. Did that get it fixed up for you right there, Jacob? I hope. So a variable that is not part of the model but affects the variables, that's going to be a lurking variable hidden outside the model. That's a lurking variable. Variable hiding out right there. I thought that was the next question. Using a linear model to predict y and x values from the ones that are used to find the model is called, using a model to predict far from, I read it wrong. That's going to be the extrapolation. It's got leverage on there. We didn't talk about leverage. And last but not least, last question. Get the whole quiz done and ask questions if you have it. Internet broke. To look for outliers and check the equivariance, a blank should be created. Really good question right here. And the thing is you want to know these questions and understand why. This is a residual plot. A residual plot is just going to show us all the residuals at one time. So to check the equivariance and to look for outliers, we can create a residual plot. And to create a residual plot, especially if we want to create one in R, so this is a really cool thing. We'll be doing this in 320 here, but check this out. You remember this thing we just did right over here? If everyone in 320 remembers, we have this plot right here. Well, watch this. I'm going to take and create a linear model from this. So do not do this for your assignment. But I've created now a linear model, and I could visualize this linear model right here. And then I could go and I could do the following, and we're going all the way back to the beginning because now I can do a check regression on this and actually look at the residual plots and see if the conditions are met for normality. Really great question for 201 and 320 right now. Do the residuals look normal or not normal? Look at that histogram. The histogram looks pretty unimodal and symmetric. Don't look at the histogram. Look at this graph. Do the residuals look pretty normal or not normal? Do the residuals look pretty normal or not normal? Careful, Nick. Everyone's thinking they look normal. But when you look at normality, what should you look at? When you look at normality, what should you be looking at? When you look at normality, what should you be looking at? Should you look at the histogram or should you look at the normal quantile plot? Do you see right here that we have this deviation up here and we have this deviation down here? So don't look at the histogram. And we're not going to talk about means and medians here. We're just seeing if the residuals look normal. This is something we'll be doing later. This is for linear regression, which we're starting that this week? Oh my gosh. I think we are. Everything just flies. I was doing the whole weekend was spent doing 201 stuff. And so and a little bit of video games and watching The Great. Has anyone seen The Great besides me? Besides myself and my fiance? Has a single other person seen the Hulu show, The Great? I think it's called The Great. It's about Catherine the Great. No, The Great. It's called The Great for Catherine the Great, not The Great. The Great. You should. It's a really good Hulu show. It's got Elle Fanning in it, and it's got the guy who played Beast from X-Men, from X-Men First Class. He plays Peter, and a lot of other amazing actors and actresses. But my gosh, that show was amazing. One of the best shows I've seen in a long time. So it's funny because, I didn't know if I'd like it. And then 2 episodes in, I'm like, we have to watch all of this. So check out the show, The Great. If you like historical fictions with, it's definitely earns its mature rating, I think. So it's a really great show though. Pretty crazy. So I think it won some Emmys or Grammys. Emmys, you wouldn't win Grammys. Grammys are for music. What's wrong with me? So is 2-on class today the Kahoot? Nope. 2-on class today is just a review. Kahoot is tonight. Definitely, if you are in the 201 group me, make sure that everyone knows that the Kahoot is tonight at, what time is it your time? I think 7 p.m. your time. Let's check. Let's do a little housekeeping right here before we end the stream. But the 201 Kahoot should be tonight. I've got it scheduled on here. 201 Kahoot tonight. Show up. Prizes, 7 p.m. Eastern. 7 p.m. Eastern for prizes. There'll be at least a $20 first prize. If we get over 200, I might just be like, what the heck, $50. As long as no one crashes our Kahoot. Even running your attach and associate code, I'm still getting the error. Have you ran? Be very careful. Try this. You ready, Jacob? You don't get the points from the Kahoot. You can get points playing the Kahoot, but you don't get, if you get 5,000 points, you don't get 5,000 points. Because you'd play one Kahoot and you'd have all your points for the semester. Jacob, when you type associate and you type tip, does it show up right here? Be very careful because the attach should let you get the autocompletes right here. That way when you type tip, it appears. So then don't try to type tip. Here's the biggest hint I can tell people is use the autocomplete because it'll correct the syntax. So when you do the tilde and you type bill, pause when you start to type bill and then let the autocomplete do its thing and make sure that you have the right, it'll complete it correctly for you. You don't want to, since these have all these underscores and capitalizations and things, it's very easy to make a typo. So you just want to let it autocomplete by hitting enter, and then you want to do data equals and then ex2 tip, and then it should run. Did each of those, make sure each of them autocompletes, and then have this code. I'm just going to drop it. I'll just drop it in the chat. If it's not loading right here with this, then the issue would be that ex2 tips is not loaded in. So if you look in your global environment, if this code I just dropped in the chat is not working, then it's because ex2 tips is not here. And then you'd need to run the following code up here. Make sure to put in your student ID. And you'd run all this code up here. Just make sure this runs. This will make sure that you then have ex2 tips. Did that work out, Jacob? So hopefully that fixes the issue. And if it's still not working, email me. Also, if you think you have all the right code, you can simply just run this chunk right here. So running the chunk will run all your code. And when I'm getting a little bit of an error, plot too large, that's all right. And so it's just saying it can't make the plots. And now it should be able to make the plots. Did it still say plots too large? No, it didn't say plots too large. I was just doing the attach thing. Using all public, yes, Jacob, great job. Jacob, extra 100 points. It's just practice. The more you practice and you realize, like, here's what I should do, and you just get better at it, and you say, okay, this time I do this, and last time it worked when I do this. It's just practice. I mean, well, no duh, it's practice, but coding's like playing an instrument. And I did drop the thing for tonight's Kahoot in the chat, right? Oh, wait, I just left the chat. No. Let me go back to you guys because I've now left the chat. I have left our chat and now I'm hearing myself. Are there any other last questions? I'm back in the chat. Are there any other last questions right here? I grabbed the wrong window. Last few questions. Feel free to ask them if you have them. Let me know what you're thinking. That's to put the graphic in there. You don't have to use those. You can just load them in. You could go to Word and load them in, but that's how, if you replace that, if you put, here, a lot of people are gonna make these issues. You need to make sure that your RMD, let's write this down so everyone can see. To load the graphics in. So to load the graphics in, you gonna be all right? Okay. How to load the graphics. Easy way. Copy, paste into Word doc. After knitting. I'm going to point people to this video. That's the easy way. Or one, save the .png to your working directory. Save your RMD to your working directory. It should be saved to these things. Make sure you're in your working directory. And knit. Oh, we need to replace it. Replace. Oh no, it's got the right file name. Name your files. Name your files with the appropriate names. So it's got the names given for you. You just have to make sure you use the right names. You can change them, but then you have to change what it is. So if you follow these steps right here, just tell me if there's an issue. Yeah, these things to make sure you're in your working directory. A lot of people will have their files in their download. So a lot of people, especially with their RMD, often saved in download by mistake. So it's often people have it in their downloads and they're working out of their downloads. But the easiest way to do this is to just paste it into Word. I'll get people towards the evening being like, I can't get it to load. And I'll just be like, just load it into Word. What you do is when you create your PNG file, you just give it that name and make sure it's in your working directory. Does that make sense? So you won't replace the file. It'll just access that file when you give it that name. So when you knit, it'll look in your working directory for that file. So if you create a file with the HW4Q3A, then when it looks in your working directory, it'll say like, oh, here's this file, and it'll put that image in there. But the easiest, and you also want to check this after you knit. A lot of people will think they have their pictures and then they won't. They'll lose points on those. But always look through your file after you knit it. Be like, does everything look the way I want? Did I get excessive output? Graders have been really nice this semester, not taking off points. They should take off points. What? Word does not know about file names. .rmd is proper. Let's take away these errors. Ignore all errors. Ignore all errors. Ignore always. I think that's got it. We got 2 minutes, but great questions. 8. Hopefully this helps out. The easiest way to load in the graphics is just knit your document and then load them in. It's not a bad idea to do these steps. That's just the way to like do it in your code. But if you want, you can just knit and then load it in. I think that's got it. We will finish up right here. I think I've got it, but feel like yeah, don't worry. Once you knit it, just take a look. And if it's not in there, just go to your pictures and just drop them in there. Just make sure you look after knitting. So like look after knitting, like make sure they're there. Let's put a thing right here. Make sure they are there. A lot of people will forget to put them in there. So make sure they are there. I think that's got it. We're going to head off here. Feel free to email me questions. We had a lot of great work done today. A lot of 201, a lot of 320, 474. We got you. Feel free to ask questions, but we're going to head off. Let's see that quick outro. I'll talk to everyone later. Bye for now. You can't see that outro yet. That's for later today.